Welcome to Pure Mathematics 1, Chapter 8, Vectors, Topic Vectors. Let's see, I have a vector, which is this one, this direction, and this magnitude. And what if I draw a vectors with the same length and parallel this one? So they are the same, just one vectors. It can be over here, it can be up here, anywhere, but it in the same direction and the same length for each vector, so they are the same vectors. So this one I call vector A. So they are all vector A too because they have the same length, the same magnitude, and the same direction. A arrow, A arrow. Here I have another vector. I call it vector B. Vector B here. Here's vector B. It can be here. Vector B can be anywhere. They have the same direction and the same magnitude. So all of them are just one kind of vectors. So let me draw it like this. When I have vector A, which is this line, vector A, and now I have vector B, which is this one. Now I connect the two, which is this one. I call it vector C. You can see that when I move from this point, from the beginning of A, the vector A, to the end of the vector A, the end of the vector A, also the beginning of the vector B, and I move to the end of the vector B. So the total movement of mine, the total displacement of A and B will be equal to the displacement of C, because it's just moving from the beginning of A to the end of B. So we have vector A plus vector B equal to vector C. Okay, let me take another example. And now I have another example for you guys. Here's I have one vector here, I call it vector X, and here another vectors, I call it vectors Y, and here I have this vector, which is vector Z. So which equation we can form from here? You can see that movement from the beginning of vector Y to the end of vector Z is equal to the movement from the beginning of vector X to the end of the vector X. So we have the equation X equal to Y plus Z. Remember that the displacement from this point to this point plus with the displacement from this point to this point the same as the displacement. We see the length is not the same, but the total movement, the total displacement is also the same. So we can consider it as equal vectors of X equal to the vectors of Y plus vector of Z, because it's not related to magnitude in here. It's just related to the position that you want to move. In question related to geometry and vectors, it's really hard to identify which one's equal to which one plus which one. So you have to face up with this kind of questions. Let me say here's vector X, here is vector Y, and here is vector Z. So how can we fill in the form of dot 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 equal to dot 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 plus dot dot dot? And then look at here. I have a tip for you guys. When the end of a vector is also the beginning of the next vector, so that are the two component vectors for this equation, and the rest one will be the ones in here. And look at here, the end of this one is this point. It is not a beginning of another vector, so it's not correct. And the end of this one, of these vectors, is the end of the vector Z is also the beginning of the vector Y. So Z and Y will be the two components, Z plus Y, and the rest one will be X. This is how to identify which one is equal to which one plus which one. And now we will talk about vector represented in a coordinate system. So we have our coordinate system based on two axes, which is y, and here's x. Here's 1, 2, 3, 4, and 5. Here's 1, 2, 3, and 4. Let's say we have something like this. For this case, we are talking about vector in 2 dimensions, which only contain x and y, which is a plane. But later on in videos, we will talk more about vectors in 3 dimensions. We contain one more axis, we call the z-axis. And now I will go and talk about the vector in 2 dimensions first. If I have the vectors like this one, here's my vectors. This point is my vectors. If a vector is represented in a coordinate system, it will have 2 components. In order to move from this point, we can move from here to here, and then from here we move up here. Also 2 components of a vector, right? For each of these, we know that the length of this one is 4 units, from 1 to 5, meaning it has 4 units. From here, we have from 1 to 4, so it is 3 units. When a vector is presented in a coordinate system, we need to add the value here, 4i and 3j. Why? This vector is represented at this form. Why is that? This one is 4i plus 3j. Because x value, I, mean that I and j are the unit vectors. Unit vector has magnitude of 1. So if we represent it like in this form, I is represented the x-axis and j represent the y-axis. So when we write in this form, they know that r, this vector, move 4 units in the x-axis and move 3 units in the y-axis. If we have a vector which is moving like this one, -1, -2, and here's -3, and we have a vector which will go from here to this point. Here, if it go like this one, so it go in this direction first, and then it go in this direction. So we will represent this one, this vector, in the form of I and j. So we will have it move -1, -1i, plus with it move after the y-axis. So we have 2j. And in another case, if we have something like this, 2 -3, here, have something move like this, right? And it move down the y-axis and then move along the x-axis. So we present this one in the form of 2i minus j. Okay, that's how we present the vectors. And we have another form to present the vectors. If 4i, so 3j, we can write like this, 4 and 3. They can understand that it stands for I and j. They know that when you write 4 first, it means 4i, and you write here, it means 3j. And this one will be represented at -1, 2, and this one will be represented at -2 and -1. It can be represented in the form of x and y, where x, I, plus y, j. And now we will look at vector in 3 dimensions. So the vector that we are looking for is vector OP from O to P. It is presented in 3 directions, x, y, and z, 3 dimensions. And you can see that it moves along the x-axis 3 unit vectors. So we have 3i, because I is 1 unit vectors of x. It moves along the y-axis 4 unit vectors. So we have 4j, and it moves after moving along the y-axis. We have this point here is q, and in order to get to this point, it moves up the z-axis 1 here. So with 1k, and k, remember that k is a unit vector for z-axis, and we can represent this one in this form: 3, 4, and 1. Everyone can understand that, okay? And now I want to find the vector to a point here, like this point, and then I will find a way to get into this point. So first I will start from the origin. I move 2 along the x-axis, then I move 3 along the y-axis, which is this one, and 3 along the y-axis. So first I have 2i plus 3j, and then I move up here 2 more. Yeah, see that? Move 2 more, so I have 2k, and it represents the vectors OM, something like that. Okay, so OM equal to, here's a OP equal to, and here's OM equal to, and it can be represented like this form: 2, 3, and 2. OM equal to this one, and here's OP. That's how we can look at vectors in 3 dimensions.